In this video, I want to find the value of the inverse tangent of a negative ratio. I'm just going to make up negative square root of 3 because in the last video I made I promised I was going to do this. So first off, what I want to talk about is this inverse notation, that this tangent appears to be raised to the negative 1, but I want to remind you that this is just the name of the function. It's like back in a previous course where you learned how to evaluate a function f of negative square root of 3. You learned that there's not multiplication here, that this was the name of a function, and we're just saying what would the output be if we input this number into this function whose name is f. So same thing is going on here. The inverse tangent, this notation here, is just the name of the function that we're using, and we're giving you its input and asking you for its output. Also, I want to point out that there's an alternative notation for inverse tangent, and that's arctan. So some of the problems you're going to see using this notation, sometimes we use the notation arctangent. I prefer arctangent because it doesn't involve that negative 1 power, and students get confused thinking that something's being raised to the negative 1 power, which is absolutely false. It's just the name of the function. We can name it whatever we want, and that's just how they named it. On the other hand, you realize that when you go to your calculator, they don't use arctangent notation, and they use the tangent to the negative 1 here. So you should get used to both notations. Anyway, back to the problem. I want to find the inverse tangent of negative square root of 3. First thing you need to know is that there's infinitely many answers. There's infinitely many angles for which the tangent comes out to be negative square root of 3. So if I'm doing the arctangent of negative rad 3, that's the same thing as the inverse tangent. And one thing you're supposed to know is, your calculator doesn't give infinitely many answers, and there are infinitely many angles. Right? The answer to this is the angle whose tangent is negative radical 3. And the calculator has to pick one. And the calculator always, when you do inverse tangent, always gives you an angle either in quadrant 1 or quadrant 4. Now, I can tell you which it's going to give you based on the input you give it. So if you remember with the acronym all students take calculus, you would remember that in quadrant 1 all the trig functions are positive. It means tangent is positive in this quadrant. If you take the tangent of an angle in here, you're going to get a positive ratio. I don't have a positive ratio. I have a negative ratio, right? Negative radical 3. So the answer my calculator is going to give me is not quadrant 1. Well, I said the inverse tangent always gives answers in either quadrant 1 or 4. The angle it has to be one of those two. It always does that. But because I gave it a negative ratio, it must be quadrant 4. Remember, in quadrant 4, cosine's positive, meaning sine and tangent are negative. Now, in this video, I don't really care that tangent's negative. I'm just saying it to reinforce the rules. What I care about is the fact that cosine is positive in quadrant 4 is to help me remind me that sine and tangent are negative. So if you want the tangent to come out to be negative, it's going to be in quadrant 4 here. So when I go to my calculator and I do inverse tangent of negative square root of 3, it's going to give me an angle in quadrant 4. Because I'm really big on trying the problem without my calculator, I'm going to give it a shot here. Remember what I'm trying to do. I'm trying to find an angle so that when I take the tangent of that angle, so I often say that the inverse tangent can be thought of as it's the angle whose tangent is this ratio of sides here, negative square root of 3. And because I know that the tangent function is always the opposite over the adjacent of the reference angle, I'm going to make this look like a fraction by putting it over 1. So I'm looking for an angle in quadrant 4, so that if I was to take the tangent of theta prime here, my reference angle, the opposite side comes out negative square root of 3, and the adjacent side would be 1. So just labeling the opposite side there, negative square root of 3, the adjacent side 1. Again, this is just one of those special triangles that we had you remember, that if that's how it's set up, the hypotenuse would be 2. Give myself some room to label this in here, and this would be 60 degrees. So when you do this on your calculator, we have to figure out how the calculator is going to answer this. I'm gathering that the calculator is going to answer this as negative 60 degrees here is how it's going to give its result. So when you use your calculator, and I do think that people should use your calculator, but you should be able to use the calculator to give you some of the information and understand what it's giving you, and then be able to answer questions that the calculator cannot give. So most students would start by just saying, let's just see what the calculator gives me. I'm going to hit mode to make sure, what's the calculator going to give me. It's going to give me the answer in degree mode. So I'm going to hit second quit. I'm going to hit second inverse tangent, type in negative square root of 3, and indeed it gives me an answer of negative 60. That's as far as the calculator goes on the home screen. So the question I want to ask is, could you give me other answers? I started the video by saying there's infinitely many answers. There's infinitely many angles, so that the tangent comes out negative square root of 3. So what are the other ones? What are the other angles that are possible? So if negative 60 degrees is one of them, give me some others, and we'll look at this graphically and find them. So how would I find the other ones? Where else would the tangent function be negative? So there's always two places between 0 and 360 degrees. There's always two places where the tangent comes out to be negative, and also two places where it comes out positive. So if you look here, this states that tangent comes out positive in quadrant 3, and in this example I'm not going to consider that because we want the tangent to come out negative. So the other reference triangle, one of them was quadrant 4, the other place between 0 and 360 degrees, once around the circle, where tangent is negative is right here. The fact that I have an S here in all students take calculus means sine is positive. Well, that's just to help us remember that cosine would be negative and tangent would be negative. So this is the other quadrant where tangent comes out to be negative. So I'm going to draw a reference triangle in quadrant 2 because I know tangent comes out negative there. And I could repeat the process and say, the opposite side the opposite of adjacent has to be negative radical 3. But because I'm in quadrant 2 here, I wouldn't label the side opposite my reference angle negative, right? Because the y value of this point would be positive, the x value would be negative. So if I was doing the full explanation, I would label this side square root of 3 and this side negative 1, because if I was to label this point, I would have a negative x value and a positive y. But either way, the tangent comes out negative radical 3, right? The opposite side would be square root of 3, the adjacent would be negative 1, and that is the same thing as negative square root of 3. I didn't really need to do any of that to answer this question. It's just good information. Because I've already done the hard work to find out this reference angle here. If this reference angle is 60, then this must be 60 degrees. And now I can just represent these two terminal sides infinitely many ways based on stuff you learned in other sections previous in the course. So one way to get this angle would be to rotate clockwise 180. So what would that be? That would be negative 180, right? When you rotate clockwise, that's a negative angle. And then I'd want to go 60 more in a clockwise direction, so I would subtract 60 to go 60 degrees further clockwise. So negative 180 minus 60 would be negative 240 degrees. That would just be another answer. So I'm suggesting that the tangent of negative 60 gives you negative radical 3. I'm also suggesting if you took the tangent of negative 240, you'd get the same answer of negative square root of 3. And this goes on forever. I can keep wrapping around the circle. I could go negative 360 and 60 more. So another answer would be rotate clockwise 360, I'd go all the way around the circle, then 60 more because of this reference angle here. So another answer would be negative 360 minus 60. So what is that? Negative 420 degrees. Would be another angle. If you took the tangent, you'd get negative square root of 3. Well, this is messed up. This right here I think you should ignore. It was supposed to be negative square root of 3. Anyway, I don't want to redo the video. The idea is, there's infinitely many ways to have the tangent come out negative rad 3. So if you wanted some more, you could do some positive angles. You could represent these two terminal sides in a positive way. Let me kind of erase some of the stuff because it's getting kind of ugly. So negative 60 was one of my answers. Negative 240 was an answer. Let me just kind of write some of these down and I'll verify these on the calculator in a minute. If you wanted some positive angles, well, how would you represent this angle here, this terminal side, in a positive way? In a positive way, let me see, if I went starting with the x-axis, the positive side of the x-axis, if I rotated counterclockwise, this would be 180, but we don't want to go that far. We only want to go this far right here and stop on this terminal side. So I could go 180 minus 60 would be another angle for which the tangent comes out negative radical 3. So 180 degrees would be from here all the way to here, the negative side of the x-axis. But because I wanted to stop at this terminal side here, I can think of it as 180 is too far. Let's back up 60 degrees. So what is this? 120 degrees would be another angle for which the tangent comes out to be negative square root of 3. So let's verify these things on my calculator and see if I am correct. Let's just go to my calculator. I'm in degree mode, remember. So let me go back to my home screen, clear the screen. Let's take the tangent of negative 60. That's the one that the calculator gave me. That's one angle for which the tangent should come out negative radical 3. This, by the way, is just the decimal approximation to negative square root of 3. So to verify that, let me type negative rad 3 on my calculator to show you that, yeah, the tangent negative 60 is indeed negative square root of 3. This is one angle that the tangent comes out to be negative square root of 3. So ding ding, got one answer. Negative 60 degrees is one angle, so that the tangent comes out negative square root of 3. I wanted to find more since there's infinitely many answers. The calculator gave that one for free. Remember, the calculator gave me that one for free by just typing in inverse tangent negative square root of 3. For free, it gave me one of the answers is negative 60. So that's what a calculator gives you. The human now has to say, well, what are the other answers? Suppose I don't want the answer negative 60. What if I want an answer that's positive? So I came up with drawing these reference angles, saying if you wanted one positive answer, you could go 180 minus 60, which was 120, and that would be an answer. That's an angle whose tangent is negative radical 3. So let's try that. Let's take the tangent of 120 degrees and show that I indeed get negative square root of 3. Another answer that I came up with, if you remember, was negative 240. What is the tangent of negative 240? Well, it's just another angle for which the tangent is negative square root of 3. So hopefully I've convinced you there's infinitely many answers that you could get. If you wanted one more, one answer would be 300 degrees. Because once around the circle would be 360, and because this reference angle here is 60, let me see if I can pick a different color here, running out of colors to show. Let me say that going once around the circle is 360, but if I wanted to go not the whole way around the circle, but I wanted to stop at this terminal side right here, I'd have to back off 60 degrees. So think of 360 is too much. I'd have to back up 60 degrees because I wanted to stop here. So that would be 360 minus 60, which is very easy to do in my head. That's 300 degrees. So 300 degrees would be another one. So I think you get it by now. Let me just do it. The tangent of 300 degrees, I'm in degree mode, is another answer where the tangent comes out negative square root of 3. So to make some connections here, let's go to y equals and graph the tangent function. And let's graph negative square root of 3 and show you why there's infinitely many answers graphically. So remember, in a previous course you could solve equations by using your intersect feature. So what exactly are we solving? What is the equation we're solving? When we said find the inverse tangent of negative radical 3, another way that the question could be written was find the angle whose tangent is negative radical 3. So what we're really solving is tangent of x, right? What angle? X is an angle. What angle has the property that if I take the tangent of that angle, I get negative square root of 3? So evaluating the inverse tangent function is exactly like solving this equation. They are the exact same thing. If I said, here's this an equation, solve for x, it's the exact same thing as saying evaluate the inverse tangent function at this number. So I'm going to type this into y1, this into y2, use my intersect feature to find the solutions. You're going to find there's infinitely many answers, some of which I've labeled in this video. Negative 60, negative 240, 120, 300. Since my video worked out answers say negative 60 to 300. Let's go negative 360 degrees for my x min on my calculator. Let's go on my x max positive 360 degrees. Obviously, you can go to negative infinity to infinity, and well, you can't graph that in the calculator, but the idea is there's infinitely many answers. Let's just look at some of these. Let's look at one time around the circle in a positive fashion and one time in a negative fashion. So on my graphing calculator, I've typed in tangent x into my y1, negative square root of 3 into y2. I'm going to go to my window. I'm going to go negative 360 degrees. That would be once around the circle in a clockwise fashion. Positive 360 degrees would be once around the circle counterclockwise. So when I graph this, you're going to see several cycles of the tangent function. In a previous chapter, you learned that tangent needs pi units, or in degrees, 180 degrees to do one of its cycles. So we're going negative 360 to 60, so we're seeing lots of them. So it turns out from negative 360 to 360, there's 4 answers, and I believe I found them. The 2 negative answers here are negative 60 and negative 240. So this one's going to be negative 60. It's going to have an x value of negative 260. This intersection is going to have an intersection of negative 240. My positive answers were what? 120 and 360. So you can see that here, that they intersect right here at a positive angle of 120. And I misspoke when I said 360. The other answer was not 360. That's just my x max. The other positive angle we found was 300. So on 120 and 300, so I'm gathering that this intersection has an x value of 120, and this intersection has an x value of 300. So I'm not sure I want to find all of these in the video. You can just do it on your own time, but to do one, it would be second calc, select number 5 for intersection. Is this the first equation, tan x? Yes, by pressing enter. Is this the second curve, negative rad 3? Yes, by pressing enter. I don't know which one you want to find. Let's just find the first positive one. Let's do this one right here. So if I put my guess near this intersection, it's going to find that one. If I press enter, it thinks about it, and it says intersection at 120 degrees. So it's finding the answer I found right here, 120. So now I'm going to proceed to make a video for sine and cosine. Not that it really is any different than tangent. It just perhaps plays out slightly different with the angle. So remember, I started the video saying that the inverse tangent gives answers on your calculator in quadrants 1 and 4. That's true for inverse sine as well, but not true for inverse cosine. For inverse cosine, the answers come out to be in quadrant 1 and in quadrant 2. So perhaps just because it plays out a little differently, I'll make a video for inverse cosine next. So